Alright, today I gave you the Algebra 1 Test 15 practice, and we just went through each problem and figured out each of these things so that you're ready for the test tomorrow. Each of these problems, there's going to be one just like it on the test tomorrow. Legitimately just like it. I'm just going to change some numbers around. So let's figure out how to do each of these. Is the point 24 a solution to the system? Okay, system, these are my two lines. Is the point 24 a solution? That just means, do these two lines intersect at 2, 4? The only way to find out is if 2, 4 works in both equations. So here's how we do it. Rewrite the first equation, 2. I'm going to put in a 2 for x, plus 5, 4 is y, equals 24. Check and make sure this works. 4 plus 20 equals 24. 24 equals 24. It's true it works in the first one. Got to make sure it works in the second one. So I'll rewrite the second one. It says y equals x minus 2. So for y, I'm going to put in 4, because that's what y is, equals x, which is 2, minus 2. 4 equals 2 minus 2 is 0. Does 4 equal 0? No. Since it doesn't work in both of them, is it a solution? No, not a solution. So all you do is check it in both of them, see if it works. If it doesn't work, not a solution. Number 2 says, is the point 0, 0 a solution to the system of inequalities? We're going to do the same thing. We're going to check and see, does 0, 0 work in both of these? If it does, it's a solution. If it doesn't, it's not. Put in the first equation. 0 is less than or equal to 0 plus 5. Which just means 0 is less than 5. Excuse me. That just means 0 is less than or equal to 5. Is that true? Yes, that one works. How about the second one? 0 is greater than or equal to 2 times 0 plus 1. That means 0 is greater than 1. Is that true? No, not a solution. So if it didn't work in the second one, which it didn't, it's not a solution. Those should be easy plug-in problems for you. Number 3 says, what is the solution to the system? A solution is where two lines intersect. I know it's hard to see, but we can count this. Just give me the ordered pair. It's 2 on the x-axis, 3 on the y-axis, 2, 3 is my ordered pair. X is first, y is second. Everyone wants to make this mistake that they want to put the y's first and the x's second. That's only for slope. For an ordered pair, it's x's then y's. Ordered pair. 4. I want what is the solution to the system? Again, where do those two lines intersect? It's hard to see on this, but those two lines intersect. The x, it's negative 1, 2, 3, 4, 5. And on the y, it's negative 3. So the ordered pair is negative 5. X is first, y is second. Negative 5, negative 3. 5. Graph the system. If you're going to graph a system, make sure they're in slope-intercept form, and just figure out the slopes and the y-intercepts and put them on there. This first line, is this in slope-intercept form? Yes, because y is by itself. The y-intercept is negative 3. I go down here to negative 3 and make a mark. Slope is 2 over 1, so I go up 2 over 1. That's all I really have to make this line. I could count more if I wanted to. That would be the next point. And I draw my line. Second one, y equals negative x plus 3. I go up to positive 3. Is it in slope-intercept form? Yes, because y is by itself. Y-intercept 3. I put a mark at 3. Slope. Negative x. Well, I need a number there, so I'm going to put negative 1 over 1. I'll go down 1 over 1, down 1 over 1, down 1 over 1. And there's the second line. Yeah, you could give me the intersection if I'd asked for it. The intersection is at 2, 1. I didn't ask for it. All you had to do is graph, but that is the intersection if you had to know it. I'm going to flip to the back, and there's a couple hard problems right on the beginning of the back. What is the system of inequalities graphed below? Okay. This is the shaded region. I just put the triangle in there because I made it in the computer. That's a shaded region. I need to write these two inequalities. I'm going to do the vertical line first. Vertical line is always x and then stuff on the other side. That's the only time it's an x on the left side, otherwise usually it's a y. The x is going through the point negative 3, so I know it's a negative 3 on this side. This is how vertical lines always work. Vertical line is always x equals a number. In this case, since we're doing an inequality, it's not going to be an equals, it's going to be a greater than or a less than or something. So this vertical line is shaded to the right. Those are the numbers that are bigger than negative 3, so it must be greater than or equal to negative 3. The equal to then is because it's solid. The other line, y, I need to figure out what kind of inequality goes in there, so I don't know yet, so I'm just going to put a circle. I'll figure out what it is in a second. I need to figure out the slope and the y-intercept. Well, the y-intercept is 2, so it's a plus 2. Slope is down 1, right 1, down 1, right 1. So negative 1 over 1x. I've shaded below and it's a solid line. Shaded below, solid. And y is less than or equal to negative 1x plus 2. You can write that as negative x. You don't have to put the negative 1. And that's the answer. That's the system of inequalities. 7. What's the system of equations graph below? All I'm going to do is get the slope-intercept form and write them. Bottom line first. I'm going to do this line first and this line second. First line, y equals, I know there's an x right here. All I need to do is give me the slope and the y-intercept. Y-intercept is negative 5. You can count that. Negative 1, 2, 3, 4, 5. Slope, up 2, right 3. That's the first line. Second line. So now I'm going to go to the second line. This was the first line. This was the second line. Y-intercept, 2. I can actually already have the x in there. Slope, down 2 over 1. Down 2 over 1. And there's my system. 8. Are the following lines identical, parallel, or intersecting? If I want to know if it's parallel, identical, or intersecting, I need to put them both in slope-intercept form. The first one's in slope-intercept form. Second one, I can put in slope-intercept form by dividing by 3, which gives me y equals 3x plus 2/3. I have this line now and this line. They have the same slopes, different y-intercepts. If you have the same slope and different y-intercepts, the two lines are parallel. Number 9, are the following lines identical, parallel, or intersecting? Neither of them is in slope-intercept form, so I'm going to put them both in slope-intercept form. The first one, subtract 2x. I get 3y equals negative 2x plus 9. Divide both sides by 3. And that new equation is y equals negative 2/3 x plus 3. Second one, get in slope-intercept form, subtract 5x from both sides. 3y equals negative 5x plus 12. Divide by 3, divide by 3, divide by 3. And I get y equals negative 5/3 x plus 4. I look at the slopes. Negative 2/3, negative 5/3. Are they the same? No. If the slopes are different, then the lines are intersecting. And that should be easy money. As soon as you see those slopes are different, it's going to be intersecting. Last one, 10. How many solutions does the following system have? This question is asking, are they identical, parallel, or intersecting? Because once you know that, you know how many solutions. Put them both in slope-intercept form. This one's in slope-intercept form. Bottom one, put it in slope-intercept form. So we move the x's over, we're just going to get y by itself. Negative y minus 1 equals negative 3x. Y is not by itself yet, so I'm going to add 1 to both sides. I have negative y equals negative 3x plus 1. Divide by negative 1 on both sides. Y equals negative by negative is positive 3x. 1 divided by negative 1 is minus 1, sorry, minus 1. So my two equations now, this is the one I just found. This is my first one. Y equals 3x minus 1, y equals 3x minus 1. That means those two lines are identical. How can I tell? Because they look exactly the same. How many solutions does identical lines have? How many times do they intersect? Infinitely many. Infinite. And that's our solution. Study this. Make sure you can solve each of these problems because all these are going to be on the test tomorrow. And good luck on the test.